Hello, cat girl. Aurora. Here's the slides in the chat. Let's wait a few more minutes till other people gather. Let's give them a few minutes. I will give a shout in the channel. Right. Student. All right. Okay. Hello, Michael. Michael Fox. I don't know how to pronounce that, sorry. Never learn. Let's wait one more minute before we start. Good evening, Krolov. Hello, Russia. All right, let's start. No, you're not. You're not the only student here. Hello, Antero. Okay, so today's lesson, lesson 9, is all about encoding. We'll be talking about the different encodings there are, a little bit about history, and this is actually quite a geeky lesson. Just a little bit of it will be C#, most of it will be about more about how computers work and how can you actually oh no, how can you actually print characters in emojis in console and stuff like that. So I hope you'll enjoy, and let's get to it. So this is the agenda. Static. Does anyone else hear static? Okay. So I'll continue. Oh, okay. So the agenda of today is to talk about um, the very basics of what makes data and the um, numbers um, which with which our computers operate, and about encodings, what kind of encodings there are, what are the differences, and how do we actually do that in C#. So first let's start with numeral systems, and of course the basic numeral system that we as humans use is the decimal system. So it's actually quite funny. We use decimals because that's the easiest way to count. And it's the easiest way to count because we have 10 fingers. And our ancestors could easily count on 10 fingers. That's why they invented decimal system, because that's that easy. And as children, we start counting on our fingers before anything else. So just tens and tens and tens means decimals. However, computers don't work that way, and for a computer to understand decimals is quite difficult. So computers use binaries, and binary works quite differently. So computers operate on bits, and bits are numbers of 0 and 1. And so to express a number such as 9, I would need to say 1001, which means that there is 1, 2 in degree 0, 0, 2 in degree 1, 0, 2 in degree 2, and 1, 2 in degree 3. So to make it more simple, you can see the list of conversions below, how you convert a binary number to a decimal number. So you just multiply the parts. So multiply the parts starting from 2 in degree 0 and raising a degree by 1 as you go from right to left. And if you want to do it the opposite, to convert a decimal into binary, you keep dividing from 2 and take the remainder. That's the most important part. So if I want to convert 5 into binary, I divide 5 from 2, then the remainder is 2. Then the whole part is 2. Then I divide 2 from 2, then I get 1. Then I divide 1 from 2, and I get 0, and I get 0, so it's done. And then I take the remainders, and that's my number. So 101 is a binary number for 5. And I do the same to 10, and 10 in binary is 1010. So this is the essence of every computer that you have, every machine that operates with electronics. And why is it binary? Simply because you have a transistor, a ton of transistors, which can be either on and off. And just by having a simple binary state change, you can make lots of combos and create complex systems such as our computers. However, well, since we don't really work with binary numbers in our daily routines, we still need to be able to understand them in some simplified way as engineers, as programmers as well. So if you ever need to deal with binary numbers, you won't be dealing them as is. You will most likely be dealing with hex numbers, which is a kind of format which takes not base 2, but base 16. So from 0 to 15, basically, you have numbers. And on the right side, you can see the picture, the chart representing the hex numbers. So hex numbers, much like decimals, 0 to 9 are the same. But when you reach 10, it's not 10, it's A. A, B, C, D, E, F. F is 15. That's the difference between decimal and hex numbers. And hex number is basically a base 16 number. Binary is base 2. Hex is base 16. So hex is basically um, um, a 2 in degree 4. That's all that hex can have. So it takes 4 bits, as you can see in the chart. And if you want to read more about hex, why is it used, why is it useful, then you can click the link below. Now let's go and move on to encodings. But before that, does anyone have any questions? Let's continue. So historically, encoding is just some code to represent a character, a letter. And the first such encoding was Bacon cipher or Braille's code. Bacon cipher first. And you might ask yourself, what's the difference between encoding and encryption? And the difference is that encoding is public. It's just a conventional way of representing a character. But encryption is something that is hidden from public. I don't know how a cipher works publicly. Only as the creator of a cipher, only as the guy who made it, I know how it works. And someone who wants to decipher a message, they will need to break the code, figure out what's the coding for it, what's the pattern, and only that way they can figure out what the actual message is. And that's why it's very different from decoding and encoding, because I don't know the rules which are based on the code making. And you can see such conventional coding patterns are just coding. That's encoding. And for computers, for text on computers to be possible, ASCII encoding was made. And ASCII stands for American Standard Code for Information Interchange. And that's basically a standard for characters that was absolutely dominating until 2003 or so, until Unicode took over. So on the right side, you can see ASCII table. And you can see it's from 0 all the way to 127. But this is just the base version of it. Since later on people decided to use bytes, because 127 is just 7 bits, but people decided to use bytes, 8 bits, because 2 in degree 3, it's convenient, that's how machines work. So they decided to use that instead for storing characters, and so this characters table was extended with 128 symbols more, as you can see here. And I really don't understand some of them. Why were they used? Like this one, or a square. Why was a square so important to be included in the chart? I have no idea, but that's how people worked, I guess. Anyways, so roughly in 2003, Unicode came into town, and Unicode is now the standard for encoding, which supports pretty much all characters. And in total, it supports 137,000 characters. So 137,000 characters is quite crazy. And how do you make such characters? Well, think about every language that ever existed and take all the characters of those languages, add emojis on top, and you have that many characters. And without Unicode, emojis would not be possible. And Unicode basically takes 4 bytes. So instead of 1 byte for storing a single symbol, a single character in ASCII, Unicode takes 4 bytes. To be specific, Unicode takes up to 4 bytes. There are different encodings for Unicode. As you can see, there is UTF-8, UTF-16, and UTF-32. And what this means is that UTF-8 takes 8 bits, but it can extend up to 32. So it's either 1, 2, or 4 bytes. UTF-16 is either 2 or 4 bytes, and UTF-32 is a fixed length, which means it's always 4 bytes. And an interesting thing about this is that, about Unicode characters, I actually have a link. Oh, no, not this one. Oh, about bytes. You said there's a great video on Unicode characters. I agree. I should give a link to that one as well. But this one was about Unicode in general, about the characters there are. And as you can see, there's just so many pages, so many encodings. Like, I can just keep on scrolling, and this just doesn't end. So yeah, there are many characters. And now let's go to programming, Bart. That's why we're here. In C#, if you want to use a code for a character that is from Unicode, you'll need to do an escape sequence. And in C#, we know that you can escape characters using backwards slash. But for Unicode characters, or to be more precise, for characters made of 4 symbols, 4 hex symbols, you will need to have a backward slash with a U letter, and then followed by 4 symbols. So backward slash U escapes 4 characters, no longer 1 character, but 4 characters. So in this case, if I do console write line and put something like that in the brackets, it will print 0. Now, how do you encode characters in C#? Again, I have a 0 character symbol here. And if I do encode, and say get bytes, it basically takes this symbol and gets its byte representation of this encoding. And if I say get characters, it converts those bytes into characters. So this takes bytes of a string, and this takes characters of those bytes, just decodes them. And key point here is that it doesn't decode byte by byte, but it decodes 4, 2, or 1 byte at a time, depending on what's the encoding. For ASCII, it will just take 1 byte at a time. Like literally, I can look at the byte and understand what character that is. However, for Unicode, I cannot, because Unicode varies and Unicode is more complex. And then if I want to convert the whole characters array back to a string, I just create a new string from characters array. So this is a basic flow of how you do encoding, decoding in C#. And to wrap this up, a little bit off topic, but a byte is basically the smallest unit of data that has a meaning, that represents something. And that's why in the last lesson we were working with streams, and streams were sequences of byte. And sequence of byte essentially is data, raw data without any formal representation. So if you have a bunch of bytes, you essentially have data. And when you work with databases and store something in database that is a file, you'll be storing blobs of data, which are bytes. And if you want a reason, to know a reason why is bytes so important, why do we use bytes, then here's a link to a video. Why bytes? Why do we store data in bytes? Why is byte the chosen format for numbers, for data? Why bytes and not something else? It's a number file video. And now let's go to the solution. And I really don't have much to show this time, except for a little demo on how to print a smiley in C# in the console. So if I put a breakpoint here and run this, you'll see that I think that's not the one. Yes. You see that it's a question mark, right? So what happened? I actually want to... Why do I have all those? Oh, those are from a long time ago. So can anyone answer why did the question mark got printed instead of a smiley? Yes, there were two answers and both answers were kind of correct, though Roloff was spot on. First thing that determines if console can print characters all together, the emojis all together, is the font. It needs to be true type font, such as Simsun or Consolos. So I select a true type font, such as Simsun, and it still printed a question mark. However, my encoding was ASCII, and so I changed it to Unicode. And if I change it to Unicode and do it again, you can see a nice smiley face. Just look at it. Beautiful. And the one that works, both work, UTF-8 also should work. I'll just close it, run again. UTF-8 works as well, because for 4 bytes, because this is just 4 characters, so no problem. However, if I print something like this, or just copy paste this, so this is a, actually let's copy paste the robot as well, the Twitch emoji. Okay, it's just those characters, doesn't work. Anyways, if I copy paste that one, this is the emoji, and if I try to print it, you see it's gibberish. Like, I cannot read it. Console doesn't understand it. Why is that? And the answer is that the answer lies in here. If I try to cancel that symbol, see what happens? I canceled 4 symbols, as the escape sequence does, but there is that one bit that I just cannot get. So this one has 4 bytes and I need 5. That's why I just cannot print it. So if I print something like this, you can see it's not that, because that one symbol wasn't taken. All right. Emojis. However, even though only 4 bytes are supported, so interesting thing, if I try to make encoding like this one, you see it's not supported in console. This encoding is not supported. And there's nothing you can do to support it. There is an ongoing project called Windows Terminal, which adds the support, but it's in preview right now, and you cannot really properly use it yet. So this is not supported. And by default, Unicode is UTF-16. Now, let's print some emojis, shall we? I have a list of emojis. Emojis. Stop. Actually, I don't need this. Stop. Skull. Smile. Flag. Pirate flag. What else? Warning, happy chill, very sad. happy, chill, very sad. So you can see if I print all those, I get this. The flag wasn't really printed, but it's quite cool to see all others. And it's quite cool to, you know, have an error with a skull mark or have a warning with a warning sign or a sad face. Anyways, so what are we doing with this? Like I said before, to encode this into ASCII or into Unicode, we first get the bytes from the string, and then we convert those bytes into characters. And finally, we convert those into a string. Actually, I'll put the breakpoint here. And let's see what are the results. You see, if I convert those emojis into bytes in ASCII encoding, they will not work. And conventionally, when something isn't working, is unrecognized in ASCII, you see we got 63 byte value. And if I go back to this ASCII table, let's see what 63 is. And you can see here that 63 is actually a question mark. So if I look at the byte array and I see 63s all over the place, then that means that after it gets printed, it will print question marks or 63s, in other words. Let me print it as it is. Yes. So you see ASCII, it was printed like this. Unicode, it was printed like this. And the other part I'll explain soon. Anyways, question marks, it was unrecognized. So if you see question marks in your code printed in the console, then that means it's unrecognized or that you just use wrong encoding. All right, let's continue. However, if I look at Unicode bytes, you see there are 2 times more the bytes compared to the ones that were from ASCII. 8 bytes versus 16 bytes. 8 bytes because 1, 2, 3, 4, 5, 6, 7, 8. 8 symbols, 8 bytes. However, in Unicode, it's 16 bytes. So Unicode was taking 2 bytes per symbol. And you can see the bytes here. And I made a method here that basically takes the bytes, byte by byte, and it prints out the byte value in hexadecimal. And appends that to string. So when I run my program, I have hexadecimal values of those emojis. So question mark was 3F, as you can see. And in ASCII, you can see it's 3F printed in hexadecimal. It's byte value converted into hexadecimal. Now, Unicode is actually a wild one because I cannot explain why, but if you look at the emojis here, you can see that the first one, being the stop sign, is actually not D426. It's actually 26D4. So somehow, some way, it started from the most from the minor bit going to the lower bit, and this is perfectly fine as long as it's consistent. So remember this, that in encodings, bits can be swapped in order, and this is called big endian or small endian notation, where big endian means you start from the most significant bit, and small endian means that you start from the least significant bit. So in this case, I started from the least significant bit, or I should say byte, hex to be precise, and yes, and I moved forward. So two hexes. So one hex, two hexes form a character, a Unicode character. So 1, 2, 3, 4, 5, 6, 7, 8. Just like the emoji count. And yeah, that's, if we swap each pair, you'll see the exact same values as there in the escaped codes. Does anyone have any questions? In that case, that's pretty much all I wanted to show today. And I will move on to Kahoot. So for Kahoot, where is it? Oh, no. For Kahoot, this is the number ID, and you need to go to the following website. I know this lesson is short, but I really didn't want to miss it, as it is quite a lot of fundamentals and theory, and I really think that it should be taught, because not hearing about those things is quite bad. I sadly today see quite few viewers, so not nice. I'll wait 1 more minute and we'll start. In university curriculum, you would spend 2 lessons about it, and that would be purely from a theory perspective. And as theoretical as uni is, I think it's better to just stay to the things that you need. so that's why it was so short. Let's start, I guess. So true or false, can bool represent a bit? Yes, a bool can represent a bit, because a bit is just 0 or 1, or in other words, true or false. And Resho, the liar, is number 1. Can int represent a byte? So it would be a waste of memory to create an array for every byte, and there is something wrong with that, with int representing a byte, because byte is just 0 to 225, and int is not sure how it is uh, in bits, but it's way more than a byte. How many bits is byte? Yes. Yeah, it's 16. I'm very bad with that stuff, with low level stuff. I always keep forgetting. But when you go to Visual Studio and just hover over something like this, you can immediately see uh, something that is 32 bits. So it's 32 bits, not 16. Yeah. No problem. I don't remember in the first place, so. How many symbols does ASCII table have? The extended version. Yeah, it has 256 and not 128, because, I mean, the extended version basically become extended because um, there was byte introduced, and byte can store 1 bit extra, so you might as well just step up your game and make the bit, that bit to use, put that bit to use. Which number is the closest number to amount of characters in Unicode? Unicode is not 256. It's all the characters of all the languages plus the emojis and all other shenanigans, so it's a lot more than just 256. Can character with code 1F600 be escaped using /u? And the answer is it cannot, because it has five hexes. However, you can only escape 4 of them with the /u. Ten is a binary number. What number is it in decimal? Yes, it's 2. Ten is a hexadecimal number. What number is it in decimal? It cannot be 10. When you convert from one system to another, it never remains the same. However, it's 16 times 1 plus 0. Ten would be A, but if 10 is hexadecimal, that means it's past F. So if it's past F, it becomes 1 and then 0. Will the expected character be printed to the console? It will not, because it's ASCII and ASCII does not support emojis. It needs to be Unicode to be supported. Well done. 6 out of 9. We have Fox, Roloff as well, 6 out of 9, and dominating everyone today is Aurora. Well done. Enjoy your moment. All right, now the homework. So for the homework, again, I'll create a branch actually just now, and I'll stop streaming.